Okay, so we had a little bit of trouble on our formative, so I wanted to make a quick video going over the two problems. So the first question asks us to find the equation of a line that would be perpendicular to this line and through that specific point. So in order to do this, I'm going to start out by drawing a little sketch, but I can't sketch this equation until I get it into a format that makes it easy for me to pull out some information. So I'm going to try to get this into slope-intercept form by rearranging and solving for y. So I'm going to subtract 7x from both sides. And then I'm going to divide by -2 on both sides. Now, when I divide by that -2, all three terms are divided by -2. And we have to be careful with these signs. Notice how a negative divided by a negative gives me a positive 7/2. And one thing that was a common error was that sometimes we forgot that it's way more helpful for us to have this in the form of a fraction. You'll see why in a second, but go ahead and make sure you leave that as a fraction. So now I've done my algebra, right, to rearrange. And I'm going to use this information to get the slope and the y-intercept so that I can draw a quick sketch of this. Okay. Another common error was if we rearranged our equation and got it written like this. That's totally okay, but keep in mind that this value that's the coefficient of x is still the slope. Okay, so just a quick reminder there. So I'm going to draw a quick sketch. So I have a y-intercept that's negative and a positive slope. So I can draw an approximate drawing of my line like this. So all I've done so far is draw the equation of the first line. What I am trying to ultimately do is write the equation of a perpendicular line that goes through this point. So I'm going to sketch this point. It's going to be pretty far down here somewhere. And it's okay if it's not precise, but I do need to mark it, right? It should be in the correct quadrant. And if it is going to be perpendicular, they should make a right angle. So when I draw my line, it should look like I have two lines that are truly perpendicular. If I didn't draw it to look perpendicular, then I didn't draw it correctly. Okay, so that's my diagram. So I have now done my algebra. I've drawn my diagram. I have drawn the equation of the line that I'm trying to find. Now I need to actually find that equation. And I like to always organize this by point and slope because that's the ultimate goal. If I can find a point that's on my line and the slope of my line, I can write an equation. So the only point that I actually know for sure is on this line is the point that they give us, so 5, -12. So there's my point. Now the slope of my other line, my pink line, was 7/2. Keep in mind that a perpendicular slope is always the opposite reciprocal. Okay, so my perpendicular slope should be the opposite sign. So this is positive 7/2, so I'm going to have negative. And the reciprocal fraction, so 2/7 instead of 7/2. Remember when I said you should leave this as a fraction? This is why, because then we get a nice fraction. It's very easy to take the reciprocal of. If you had written this as 3/2, that's fine. Or sorry, not 3/2, 3.5. That's fine, except then a lot of people, when they got to this point, they said 1/3.5. We don't like to leave decimals in our fractions, okay? So make sure you just leave your slope as a fraction and you won't even have that issue. Okay, so now the last step is to take this information. I made those conclusions, right? I've determined that the slope was -2/7. And now I need to put this into slope-intercept form. Okay, so my point, here it is, x1, y1. So I have y minus a -12, so that's plus. I have my slope that I found is -2,7. And then my x1 is 5. So here is my equation. So that's the last step, is I had to find that equation. There was no justify on this problem. Okay, so let's take a quick look at the second one as well. Okay, now this problem asks us to figure out if these two lines, so a line right here that's given to us, and this line that is given to us in the form of 2 points, if they are parallel, that would mean they would have the same slope. If they are perpendicular, that would mean they have the opposite reciprocal slope, or neither, which would mean they have neither the same slope nor the opposite reciprocal slope. So in order to do this problem, I saw a lot of us sketching it, and although that is a great strategy to help generate some ideas, a sketch is not precise enough for us to be sure if two lines are parallel or not. Watch, if I draw two lines, I could say those look parallel, but they could be off by just a couple degrees and we wouldn't know for sure, okay? So a sketch is not precise enough to be sure, so I need something more precise. I need to calculate the slopes because the slopes are very precise, okay? So I'm going to rearrange this equation right here. I'm going to subtract 2x from both sides. Okay. Now notice I'm keeping this in that slope-intercept form where the x comes first, just so that I don't get confused, because the slope always goes with the x. And I'm going to divide by -8. Here's another opportunity that we have to be very careful with our negatives. -8 divided by -8, that goes away, right? It reduces to make 1. A -2 over a -8, that reduces to 1 over 4. And then 16 divided by -8 is -2. Okay, so a common error was losing the negative here or losing the negative here. So make sure you're keeping track of those. Now, this is our slope, right? Because it's the coefficient of the x, this is our y-intercept. Even if I had them written in a different order, the coefficient of the x is always our slope. Okay. Now, I still want to find the slope of my other line, but this time I'm not given an equation, I'm given 2 points. So there are a few ways that you might know how to find the slope between 2 points. You might do it in a table format, like this, or you might do it in an equation format, like this. Either one is fine, whichever one makes more sense to you, you should use. In the table format, you're looking at the change in the y, so that was up 4, right? And the change in the x, so that was +2. And your slope is the change in the y divided by the change in the x, so 4 divided by 2, which is 2. If you were to use the equation format, that's fine. You would name this one x1, y1, this one x1, x2, y2, and you would substitute. So 7 minus 3, make sure the y's are on top, right? Rise over run, and then 4 minus 2. And that would give you the very same 4 divided by 2. Now, I want to emphasize, you don't have to do this and this. Just pick one, whichever method works for you. But now that I know my slopes, I can use that to determine if they are perpendicular, parallel, or neither. Now, what I'm noticing about them is that they are not the same slope. So they can't be parallel. And they're not opposite reciprocal slopes, so they can't be perpendicular. So they are neither. If parallel, they would have the same slope. And they don't. Right? Those are not the same slope. If they were perpendicular, they would have opposite reciprocal slopes. And they don't. That is my justification. And I need to really emphasize how I know that they're not parallel and how I know that they're not perpendicular. And the only way that is super precise for us to be sure that they're not parallel or perpendicular is by looking at the slopes. Okay? Now, this problem, let's see, we did algebra to solve for the slope for both, right? That was our algebra. Then we concluded that they were neither. And then my justification explains how I know that they are neither. Okay. Good luck. Ask lots of questions.